Hello everyone. In this tutorial we'll make a Flutter game and Flutter 2D snake game. Let's go ahead and see what happens or what we'll be building at the end. So this is a snake which you can control through this control panel and eat something or eat the food for the snake. So let's hit it one more time, and as you eat you get score as well. You can see from there. Yes, now score is a 10. Now the food is here. Okay, well, we died anyway. So this is what we'd be building. There would be a snake, a control panel, a food, score, and a dialog box where you can start everything from again. All right, so without further ado, let's get started our coding. And I'll be building a completely new Flutter tutorial. We'll be building everything from the scratch. So I'll create a I'll create a new tutorial. So let's go ahead and create a new Flutter project, and next let's give it a name. We'll call it snake. Well, it says already exist, or we can call it YouTube snake. All right, and it says it exists, so we call my YouTube snake. All right, let's go ahead and finish it. Now it'll create a project for us, and it's doing it. Okay, and we'll open it in a new window. Okay, so this is the old window and this is the new window, and we'll close our old window. Everything will start from the scratch, and here this is our Flutter project, and over here we have a main file, and we'll create more files over here later on. So in this file we have a lot of unnecessary code which we don't need, so we can go ahead and delete them, and we can only keep this one. And over here we can create a new Dart file, and we'll call it game page, and it won't have any parameters. And now we'll go ahead and create this file. So within lib folder, I'll call and create a new file. I'll call it game.dart. Okay, and it would be a stateful widget. Let me call it game page. Okay, and over here, instead of returning a container, we can return a scaffold widget, and that's it. Now go ahead and import this Dart file, import this library or Dart file for the file we just created just now. Okay, and that's it. Okay, so for this one, this is a scaffold, and scaffold should have a body part. Let's define the body. The body should have a container, so let's go ahead and create a container widget. And within container we can have different things. So for us, we'll have first color, background color. So go ahead and define the color, call it colors dot say amber, little yellow. And after that we'll create a child will be with stack widget, and within stack widget we'll have children. Okay, we are using stack widget because we want to put a lot of different objects or view onto each other, so that's why we need stack. And within stack we'll have different children, and the children would overlap on each other. Right now go ahead and start the file. Actually nothing will happen though, but we can see a yellow screen that would pop up in our app. So let's wait for it. It's taking a bit of time though, so my computer might be a bit slow. As you can see, it's showing running Xcode build. Sometimes it's take a bit of time. And almost done. The app is there. Yes. Okay. Yes, so now we have this yellow screen over here, and we have this debug icon which we don't need, so we can close it from here. we'll call it called show something, yeah, debug show checked mode banner, set it to false, and run it one more time, and it should be gone as it is gone. Okay, all right. So the next thing we'll go ahead and do is get this screen width and height, and at the same time we'll define minimum X position and minimum Y position. To do that, we need to declare some variables. We'll declare 4 variables with int type. We'll call them upper bound X, upper bound Y, lower bound X, lower bound Y. And at the same time, we'll have 2 variables for screen width and height. So let's go ahead and define them. We'll define them as double because we'll be using them later for other variables and other files. So call them screen width, screen height. Okay, we are good. And right now we can go ahead and copy some of the code that I prepared early. So this is the code that we can use. So let's go ahead and see our file. Our file is here. So let me paste it over here. And it looks like we need a new variable. So let's go ahead and define this variable. We'll call it int step equal 20. So this step is equal 20, and which means 20 pixel in this case, and it would also be part of the snake piece, because as you saw earlier demo that our snake consists of many small pieces, and each size is 20, or width is 20, height is 20. So that's what it is for. Okay, and let me walk you through what's happening here. So using media query, we are getting the height of the screen, and we are also getting the width using media query, as you can see. And for X value, Y value, minimum Y value, we used as step equal 20, as you can see. So less than that, we'll do something special, or we'll define a condition during collision detection. The same for Y, lower Y bound. So 20 pixel is like this. So less than that will detect something as a collision detection, or will trigger a new condition. Okay, that's what it does. And at the same time, I'll use another function to wrap this thing. And as you can see, our upper bound Y, so which starts from here and finish somewhere here, because we are doing -20. The same for upper X bound, starting from here and finishes here. Okay, and even after that, this function might return, say, something like, this line might return something like 408. For Y, I guess it is 906, and for X coordinate or width, it might return 408, which I have done before. But this is something we don't want, like 8 and 6. We want a complete number, like completely 400 or completely 900, no extra integer. So we'll get the nearest tens. So that's how we define it. So we have a function for this. So let's go ahead and call this function. This function is this one. So I'll just go ahead and call this function. Okay, so let's wrap this thing. So get nearest tens, and the same for X value, get nearest 10. Once we have this one, it will make sure that our snake or objects, that the one we draw, it really stays into our screen, not little over the screen. So that's what it does. As you can see, say for example, we pass this value pretty much should be 9, or for x1, which is a very easy example, 408. So num is 408, and because we are using this operator, what this operator does, it returns nearest complete integer. So num is 408, step is 20, so it would return, in general, if we don't have this tilde, it would return like 208. I mean, if you divide 408 by 20, so it will return something like that, okay, or 204, I believe. Okay, so but now because we have this one, so now it will return only 20, okay, not 204. And now we divide this result again, sorry, this result, we multiply this result again using step, so which is 20 multiplied by 20 equal 40. So we get a complete number, complete 100, things like that. And if it somehow returns 0, we return the lowest value equal 20, and otherwise we return the highest value, whatever comes from here. So that's all it does. Okay, so we have gotten this one. So our next job is to find or draw a piece of snake, a rectangle or a square, and many of the square will consist the snake. So that's what we want to do. Okay, so for this reason we need to define a new Dart file. We'll call it piece. So let's go ahead and do it. So new Dart file, we'll call it piece.dart, and it would be a stateful widget, and we'll call it PIECE, piece. All right, and within piece it would return, I guess will return a positioned widget. So let's call it positioned, and position takes a child. In our case the child is opacity, because we'll be dealing with opacity later. And positioned widget has top property, and it's like, say, where to put it, like top and the left, like that, even bottom, so it depends what you use. So before we use those kind of values, go ahead and initialize them. So we can initialize them as a final int pos x, pos y, and we'll also have size at the same time. And later on we also want to use color, so define the color, final color. Okay, and we need to initialize this value in the constructor. So go ahead and call the constructor, and the first value it takes is key, and the second one could be this dot color, the next one could be this dot size, next one this dot pos x, next one this dot pos y, and at the end we'll call it super key. Okay, we're good. So now as we have this int x, pos x and pos y, we can define them here as our top and a left property. So first we'll define top in general, this y-axis. So in this case it would be widget dot pos y, and it is integer currently, so we'll cast it to double because it takes something a double value, and for left we'll define widget dot pos x and to double. Okay, and one thing you have to know why we are using positioned, because using positioned you can position something anywhere on the screen. It's more like web application absolute positioning. That's how you can understand. And if you have done web application, you know that for absolute positioning we also use a top left property, so the idea is same. If we use positioned widget, we can overlap things onto each other. Otherwise we don't need to use it, because in this game snake and the control panel, they would overlap on each other as we saw early in the demo. So this is the reason why we are using positioned widget. Okay, now we have this opacity, so go ahead and declare opacity. Current opacity would be 1. Okay, and after that we'll declare a child widget, and child widget would be a container, and container again takes width and height. So in this case, let's go ahead and set width with widget dot size dot to double, and we'll do height. So widget dot size dot to double. Okay, so we are done with this. In general, containers should have width and height, and that's what we are providing here. Remember, all these value y, x, and size, they would be provided when this object is get called from other file, like for example game dart over here. Okay, so we are done with this, and the next thing we want to do, we want to define something on the screen, a shape. So this is a container, but container doesn't have a shape, so we'll define a shape. The shape we can do using decoration, and it takes a widget. We can call it box decoration, and box decoration takes few properties. The first one is color. So let's go ahead and call the color widget dot color, well, just color. The next one is border radius. For border radius, we can call another widget called border so border radius, and border radius, all the border should be same, and radius dot circular, we'll have a circular. Okay, I made a mistake. Radius, radius, radius dot all, so radius dot circular, and it will have a circular border, like say 10 pixels, like that. And next we'll have border itself, which is defines width and color of the border. So border dot all, so all the borders should have same color and same width. So in our case 2.0, which we define, and the color could be say colors dot white. Okay, so we are done with this piece object. All we are doing, we have defined a positioned widget because we want to randomly put our object anywhere on the screen which might overlap with each other. Later on we would be dealing with opacity, so that's why we are wrapping our box within opacity. Current opacity is 1, and the box decoration should be within a container or child container, and container should have width and height. That's what we have defined. And box itself should have color, border radius, and border width, and border color. So that's it. So now we have this piece object, piece file over here. Now in game.dart, we can go ahead and use this one to define it and draw it on the screen. So the first thing we need to do is find a way to call this file and create object from it. So we can do it easily. So what we would do, we would go ahead and create a function. This function should return a list, and the type of the list would be piece. This is this file or this object just we created, and we call this function called get pieces. Okay, and within it we'll first define a variable, and it will contain a lot of the pieces we use this file to create. So later on we would use this file to create a lot of objects, and those objects would be again saved in a list. Okay, so this variable is called pieces, and the list type is again from this file or object which one we created early. Okay, and of course we need to import it. So let's go ahead and import. Okay, we are good, and now we can return them, return pieces. Okay, but of course if we go ahead and call this function, nothing will happen because we have an empty list and returning an empty pieces object, so that's not gonna work. So to draw something on the screen, first we need to have a position, and once we have the position, then we can create object. Okay, so to get position, we'll call a function called draw, or create a function. Let's go ahead and create it, void draw. Okay, and this function would be responsible for creating positions for the snakes and other things. Okay, so first we'll go ahead and declare a variable, and this variable type would be list, and well, it would be like an array. So we have list here, and within it we'll have objects, and objects type would be offset. Offset is more like point in other programming language. Point has xy value. So for offset, the same thing. We have x part and y part, and we'll call it positions, and we'll initialize it to empty array. Okay, all right. So now in this function, we'll check if positions dot length equals 0 or not. If it is 0, we'll create a position and add it in this list. Okay, so let's go ahead and add it first. But add what? So we have to create a position. So to create a position, we can create a new function. We'll call it get next position. Okay, all right. So obviously this function is not defined yet, so we'll define it. So I already have it in my file so that we don't need to waste our time. Let's see, it's here. Oops, it's not here. So anyway, if it's not here, so we'll create it on our own, so it's not a big of a deal though. Okay, all right. So let's go ahead and create it. So it will return something. It will return something like, say, offset type, offset, and let's call it, I think we don't need to call it get next position. We'll call it get random position. Okay, it's better. Get random position. Okay, and first we'll declare a variable which would be offset type. So we'll call it position. Okay, and we'll return it position. Okay, all right. Now this position should contain a position, and the position could be created using a random variable which will have upper bound and lower bound. So go ahead and call it pos x, and now here we'll call the random function in Dart, but we need to import a library for this. It didn't do it for us, so we'll do it manually over here. Dart math, so math library, and we are good to go. Okay, and now we can get next int function which takes upper bound or maximum value. In our case, for x position, it would be upper bound x, and at the same time we'll also have a lower bound x. So it will make sure that everything stays between from here to here. Okay, this is the upper bound and this is the lower bound x, and upper bound x is here. And we'll do the same for y position, pos y, and random, okay, called the next int function. So we'll provide upper bound y plus lower bound y. Okay, now we can return them in as an offset type. So let's go ahead and first put it for position, which we declared early, and wrap everything within offset. Okay, so we'll call offset. Now offset takes two values, which is x and y. So our x is this and y value is this. All right, but as we said early, we don't want to get anything weird like 40.8, not like that. We just want to get a complete integer, and that's why we need to call them using this function, get nearest tens. Okay, and after that we'll pass pos x, and because offset takes a double value, so we'll turn it to double. Very good. And again, same for the y value, get nearest tens, we'll provide pos y, and we'll turn them into a double value. Okay, all right, let's see, it should be pos. Yes, we are good. So now we have this random position, and we create this random position using this function and add it to the position list. So it is there right now. So we have a random position, And right now this random position could be drawn on the screen, so we can draw it easily. So go ahead and create an object and add it to the piece this list. So call this list first, pieces dot add. Okay, and we want to create this piece type object. So we'll call piece, and it takes few parameters as we saw already, and we define the arguments over here. It takes color, size, pos x and y. Okay, so let's go ahead and define them one by one. So pos x would be like, so we'll take the first position in this list. Right now, of course, we only have one position, and that's index is 0, positions 0, and we'll take the x part, which is dx, and we'll turn it to int. So just now we saved it as double, now we turn it to int. We'll do the same for y, sorry. We'll do the same for y, positions 0 dot dy, and turn it to int. Okay, so we have done this, and the next thing we need to do is provide the size. So size equals step. Well, right now step is 20, which is a bit small. We can do it 30. Okay, and at the same time we'll have the color value. So colors dot red. Okay, so we're good. So that's we have created one position, and that position had been passed to our piece file, and that created a piece object. And within this, after creating this piece object, we add it to the piece list, pieces list, and all we need to do, call this function, and we'll see something on the screen. So let's go ahead and call it. So we can call it from here, and because we'll have a lot of pieces and those pieces might overlap on each other, so we need to call another stack widget again, and within it we'll have children, and children will have get pieces, only one child, so we don't need that array notation, one is enough. Okay, so let's go ahead and save it. Wow, boom. So here is our first snake piece. Okay, so we are successfully able to create a snake position on the screen. So let's go ahead and run it again. Yeah, so we can generate a random position. We saw just now we saw. Okay, so that's an excellent job we have done. So the next one, so right now we only have one piece, so we can create a lot of pieces. And that means first we have to create a lot of positions. First we will create a lot of position, and then we'll add them here in a loop. Okay, so to add the position, we can do them in a while loop. In the while loop we'll see the length, but right now we don't have the default length for this snake, so we can go ahead and define a variable. We'll call it length equal 5. Okay, and we'll check if the default length is greater than positions dot length or not. These positions are saving all the positions for the snake. So right now we only have one position, so definitely this length is greater than this length over here. Okay, if it's so, then we need to create more length until it is 5 and save it in this list. Okay, so go ahead and do it. So go ahead and save it in this list, and save what? We'll save positions, and positions are coming from positions again. It's a bit complex, or sounds like a bit tricky though. So let me tell you what's happening. So after this, positions.length is 1 over here. So positions.length is 1 over here. So 1 minus 1 is 0. So positions 0 index, that means the first one. So first one we add again. Okay, so that would be actually the second position. Of course, the first position and second position, currently they have the same position, same random value. Okay, so while loop will run again, and in this time the position length is a 2. So 2 minus 1 is 1. So position index 1. So it takes the second value and add it again on this list. Okay, and right now we'll have, after this we'll have position length equal 3. So position length 3 minus 2, so positions index 2, So it means the third position we add it to the list. So what it does, it loops through it in a while loop and add the same position again and again. So after this iteration, we'll have 5 positions added in this position list, but they all have the same position. Yeah, that sounds a bit weird, but we'll change it later and explain why we have done it. Okay, so we successfully generated 5 positions, and we also want to change their position. Okay, change their position, and which would look like that the snake would be moving. Okay, right now the snake is not moving, but we want it to move. So to move it, we need to change the position, and which we'll do in a for loop. So we'll define a variable called var I equal positions dot length -1 and I greater than 0 and I minus. Okay, and after this we'll go ahead and call this list position I and positions I -1. Okay, so let me tell you what's happening here. So using while loop, we are adding the 5 positions. They all have the same positions, and using this one, what do? We change the position with each other. So say for example, this would return 4, right? Because positions dot length is 5 -1, so this would return 4. So I is 4. So in 4th position, we put the 3rd position. That's what's happening here. So let's go ahead and see. In 4th position, we are putting the 3rd position. So in the next loop, in 3rd position, we'll putting the second position, or the second one, and in second one we'll be putting the 1st position, and in first one we'll be putting the 0th one. Okay, so that's how it is going on like this. Okay, all right, so next we need to create the next position for the snake piece, and which has to be different than this position. If next position is different than this positions, and if we change like this, so it would look like the snake is moving. So let's go ahead and create it. So we'll send it to positions.0. So remember, to make the snake look like it's moving, all we need to do, we need to change the 1st position, which would be the snake head. Okay, and for this one we need to change the position. We can change the position by adding x and y value to it. Okay, so now we'll go ahead and create a function which would be called get next position, and it takes a parameter and the first object, or sorry, the 1st position of the snake. So of course this function is not defined. We'll go ahead and define this function, and which I already have it somewhere here. So this is the function I guess we need. Okay, get next position. I don't want to waste time, so let's go ahead and just copy and write this function somewhere here. Okay, well, now with this function we have some variables and objects that we need to define. The first one looks like we need to create a file for managing the position of the snake. So let's go ahead and create a file, and this file I'll call it direction.dart. Okay, and within it we'll have some enum values, and we'll call the structure as direction, and it will have 4 values. The first one is up, the second one is right, the next one is down, the last one is left. Okay, and now go ahead and import this file, which okay, we saved it. Now we should go ahead and import this file. Looks like we might have an error with the name direction enum. Okay, the error is here actually. Okay, and it still can't get it, though I thought it would get it automatically. So anyway, if it didn't, then all we could do, we could copy this line and import the file. In this case we'll import direction. Okay, and after this, yeah, the error has gone, and this is another variable we need to declare, and we'll declare it as direction type direction, and the default value will give it, so default value for now right. Okay, so we are creating it, we created another variable that's called direction. The type is direction, which is this type, and we are getting the default value as right, which is this value. Okay, so now let's look at get next position, what it does. And it's showing an error because it has this feature object, features type, which we don't need for now, and we also don't need async here, and we should be good to go. Okay, so what's happening here? So from this draw file, sorry, from this draw function, we are sending the first position to it. Okay, and first position is taken here, and after that we see the current direction. If the direction is right, which is on the x plus side, this side, so the direction is this side. If we want to move the snake, then all we could do is add a step value. Step is a 20, so in this direction we'll add 20. In this direction y doesn't change, so y stays as original. Remember, position is offset type, so which is x and y value, and on the right we just increase the y x value, y stays the same, and on the left, which is this one, we need to decrease the x value. So that's why we decrease minus step, so it comes here. Okay, and y doesn't change. And now the same truth for upper value, like y up and y down. So if we want to go y down, we'll increase y value, which we have done over here. So as we go down, the x doesn't change, so x stays the same, and after that we return this position. So what's happening here? So right now we have 5 values over here, but we take the first value and change its position. Okay, so it'll look like the value is changing and the snake is moving. Okay, yeah, so as this function will run again and again, eventually each of the values will be different. Remember, so right now we are right now over here, until now every position is same, but suddenly from here the first position has been different. Okay, because we are adding or decreasing. Okay, in next iteration, so only first one is different from the other one, but what it will do, the head position would be changed again. Say for example, and during the second iteration of this file, okay, so think it like this. So first x value is 400, second x value is 400, fourth x value, third 400, fourth 400, and fifth 400. And once we call this one, so the value would change to, for x, maybe 420. Okay, so after end of first iteration, this value is like this. And when the draw function is called again, remember, this would move to this position. Okay, because that's what we are changing here using this for loop. Okay, so this would be 420 in second iteration, and this would be 440. Okay, yeah, because we are adding 20 again and again. So eventually after 5 iteration, all this position will be a new position only because of this one. Okay, hopefully it makes sense. Okay, so now what we could do, we could go ahead and call well, we already have this function here, so we have successfully generated 5 positions. They are same, and from here the changes. Okay, so now what do we need to do? We need to call this positions in a loop so that we can change for every position in the list. Okay, so let's go ahead and declare a for loop for where I equals 0 and I, the length is less than length, I is less than length, and plus I, and we'll call this from this loop. Okay, and we need to change the index I. Okay, and let's go ahead and save it. Okay, and hopefully it'll run. Okay, so it gives you the feeling that the snake is moving, as we explained earlier over here. Okay, so successfully we have created the snake and it looks like moving, but to see the complete moving, we need to call this draw function again and again. Right now I guess this draw function is getting called only 2 or 3 times until everything has been initialized and built for this build function, and after that this draw function doesn't get called. That's why we don't see the rest of the snake. So we have to find a way to call this again and again. So we can do it within our function called init state. So let's go ahead and call this function init state override init state super dot init state. Okay, and from here we'll call a function, this function called restart. Okay, and restart should call another function. We'll call it change speed. Okay, and within speed we can do the actual loop of running. So let's go ahead and call this function change speed. Okay, and here we'll play with the timer object. So let's go ahead and call this timer, and we need to import the timer library, which is async library. And we did, and now first we'll check if the timer is running or not and it's initialized or not. So timer, whether it's say not null, so which means the object is there, and at the same time this timer is active. If it's so, we'll cancel the timer. So cancel. Definitely first time we call it, it won't fall in this condition, because the first time it is not active, it is not null either, or it is null and not active, so it won't fall in this category. So if it doesn't, then what do we do? So we'll create a timer object. So let's go ahead and do it. So timer.periodic, and it could take a function which is called duration. Duration itself takes a parameter which is millisecond, and we'll supply it as a 200, and within that we'll call set state. Set state is empty because in this game.dart file we are not doing any fancy animation. Animation would be happening in this file, so that's why set state is empty. Now let me tell you what is happening here. So this init state, which would get called automatically, sorry, I'm missing a comma here, once everything has been done and ready. So for Flutter, once everything is ready, then init state gets called, and after that we start our loop. Eventually restart calls change speed, and change speed creates a timer, and this timer is responsible for running the build method, I guess, for every 200 milliseconds. Okay, so once you have a timer in your Flutter file, it would call based on your given time. So if it calls again and again, that means eventually the draw method would be get called, because build method is getting called over here, build, and from build we called everything else. So get pieces would get called again and again after 200 milliseconds later. Okay, and after this, now if we go ahead and save the file and run it, we will see the snake is moving. Okay, let's go ahead and do it. Okay, as you see, the snake is moving. Perfect. Okay, one more time. Perfect. Okay, now the next thing we want to do, we want to create a control panel from where we'll control our snake. Okay, so let's go ahead and create a new file. We'll call it control panel.dart. Okay, and this would be a stateless widget, stateless, and we'll call it control panel. Okay, all right, and from it we'll return something, say position widget. Okay, because we want to position this panel or this widget somewhere specific on the screen, which I told you early. So position is more like absolute positioning, and it will take a child. So the first child we'll provide is a row, and let's keep it empty for now. And the caller function of this control panel will supply a function to it. So let's go ahead and declare first a function that would be receiving. It would be a void type, and it would be a function, and within it we'll have a parameter which is direction type parameter, which created earlier over here, and we'll call it direction. Okay, and the function name would be onTapped. You can call it anything you want. So let's go ahead and import it. Looks like it didn't get imported, so we have to import it manually. Package, say Flutter let's see, I can actually, what I can do, I can copy it from here, which would save our time. Okay, all right, now onTapped should be initialized from constructor, so go ahead and do it. So the constructor is control panel, okay, and the first one is key, the second one is this dot onTapped, okay, and it should be good to go. Super key takes another key. Okay, we're good. Now right now the positioned is all empty, so we want to draw different buttons here. Actually, we want to draw 4 buttons here, and 4 buttons it'd be in 1 row and a 3 column, so it will have 3 children. You can think it like this. Okay, so go ahead and call it, so what we could do, I guess we can call children, and within children we'll have expanded. So the first one is expanded widget, and expanded widget takes another child. First one will supply as a row. I'll explain actually what's happening here because it might be too much information for you guys. And again, it will take children, and the children is empty, but we can provide another expanded over here, and within it we can provide container, an empty container. Okay, it should take 2 parameters. I'll explain what's happening over here soon. So before I explain, let me go ahead and create a new file, and this file would be responsible for creating a button over here. So within lib folder we'll create a new file. We'll call it control button.dart. Okay, and it would be a stateless widget and a control button. Okay, and this button would return a opacity widget, and opacity would return a child widget. Okay, so let's go ahead and see it, what's happening here. So we can supply a container within it. Okay, all right, but opacity, because we are doing opacity, so we can actually define the opacity of this thing. Maybe not like this though. First, I guess, let's see, define the opacity itself, then supply a child, and to child we can provide a container. Okay, all right, now we are good. And container itself should have some width and height property, so let's go ahead and do it. Width say 80 pixel, and height say another 80 pixel. Okay, and what else? We can call another child, and for this child we can provide a fitted box, and within fitted box we'll call another child, and within it we'll call the floating action button, and the floating action button takes few parameters. The first one is background, so background would be colors dot green, and the elevation say 0, and after that we'll provide on press event, but on press we don't have anything here for now, so go ahead and create on pressed, and for now pass empty function, and after that we'll have a child, and within this child we'll have an icon, but right now it's empty. Okay, all right, so go ahead and create these two things over here, which we'll be receiving from the caller function of this file. So first thing we'll do, we'll go ahead and declare them. So final function which call onPressed. Okay, and the same for this one. So final icon. Okay, and we need to call the constructor for this. So go ahead and call it constructor. So the first one is key, and this dot onPressed. Next this dot icon. Okay, next we'll call super. Okay, we're good. Okay, right now we can pass it because we already have the function over here. Okay, so we'll call this dot onPressed, and for child we'll call this dot icon. Okay, all right, so this would be a button. This button will have opacity. Currently the current opacity is 1, but later on we would be playing with this opacity and change the opacity. And okay, actually we can do it now, 0.5, and the button itself has width and height like 80, and we want the floating button action to take the complete space available, so that's why we put it within fitted object, fitted box. And the button will have color, elevation is 0, which means z index is 0, and it will also have an event, press event. But right now this is just a name over here. We'll pass it from the caller of this function or file and the icon itself. So these two things would be passed from here actually. Okay, so now we go ahead and call control button. Okay, well, control button takes two things. So the first one is a function which is onPressed, and onPressed returns something. Let's go ahead and see it. So onPressed returns a function over here, or user function, and this function itself is onTapped, and onTapped takes a direction dot left. Okay, all right, and we'll have also the icon here, so we'll call it icon, and icons dot arrow left. It should work though. Well, I guess we need to import a library, material.dart. Okay, so now let me tell you what's happening. Before I tell you actually what's happening, we can go ahead and call this control panel and show it on the screen, and then I explain it to you, which would be much better. So we'll create a new function. The function, say, name it get controls, and the function itself should return something, a widget. So it is widget type. Now we'll return a widget, and return what widget? We return control panel widget, which is the one we created just now. So we'll create this function, we'll return this widget. So control panel. Okay, we'll return it, and control panel also passes a parameter which is onTapped, and onTapped takes a function, and the function has a parameter which is direction, and the object is direction, and the variable is new direction. Variable could be anything though, and it returns something to this file, and the object or variable to direction, and returns the new direction. Okay, so now first let me go ahead, save it, and then I'll explain again what's happening here. Okay, all right, so it looks like it's not working because we need to call this get controls. Right now we are not calling it, so let's go ahead and call get controls. Let's save it. Here we go. Well, the button is right there. Okay, button is right there because we didn't set position for our positioned widget. So we'll set the position left to 0 and right to 0.0. It should be double value, otherwise we'll have an error. On the bottom is 50.0. So let's go ahead and save it. So it's here, perfect. Okay, and of course we can control the snake with this, as you can see. Okay, so let me tell you what's happening here. So this is a position widget. It would be like this big over here, and it has default position left 0 and y 0, bottom is 50, and within it we created a row, and row will have some children. Okay, children could be anything. It could be row children or column children. So the first one I created is expanded, which means take all the empty space available. So right now it is taking the whole width because all the space it's taking and pushing it to the corner. That's what it is doing. And within it we have within the first expanded we have a child, which is row, and row takes children, and this has 2 children. The first one is again expanded container, and which is empty container, which means eventually empty space, and we have this button. So button is this one. Now it is pushing to the end because this is the first, so it is taking as much empty space available, and then after that a little space is given for control button. What we could do, we can change the order of this, and we'll see the button is here. Okay, so let's go ahead and see it. Yeah, the button is here and the button is working. We can control it. So what's happening here, first we draw the button, so which we did, and it takes all the empty space available. So all the empty space is here. Okay, so now let's put it back to its original position, this way it looks better. Okay, all right, so this is calling this button, and this button is sending a press event, and press event itself sends a direction, which is direction.left. Okay, that's what it's sending to this press event. Okay, and at the same time when it sends here, okay, the value at the same time has been updated for direction. So where is our direction, which is here. So as it sends the new value, it takes the new value. Definitely first time there is no value for it, it's empty. The value is given once we click on it, and this value is given to direction itself. Hopefully it makes sense. Okay, now we want to create more buttons in the control panel, and which should be pretty easy. So we can go ahead and copy the first expanded widget and put it right here. Let's go ahead and save it. We'll see 2 buttons, but they have the same direction. So this should be our left button, this should be our right button, so we'll call it right, and instead of arrow left we'll have arrow right. Okay, now let's go ahead and run it again. Yes, the button changed. We can control it left and right now, as you can see. Okay, but it's a bit weird, that's because of this one. So we'll move it to the end, which is over here. Now let's run it again. We'll see 2 buttons next to each other. Okay, and these buttons are working, and we want to have another 2 buttons for up and down. Okay, so and we want to create between these 2 buttons, so that's why we'll have another expanded over here, expanded widget, and it takes a child, and this child is column because we want to put everything in column order. Okay, all right, and it will take some children, so children, and within children we want to put some buttons here. Okay, and of course this should be up direction, and this arrow should be arrow drop up, I guess. Arrow drop up, yes, this one. Okay, now let's go ahead and save it. Yes, this is the other button, and we can create one more button, and we'll call it down and drop down. Okay, let's go ahead and save it. Perfect, our buttons are there, but these two buttons are too close to each other, so we can create an empty space, and we can create it using sized box, which takes one parameter. So we'll call it height equals, say, 70. All right, now let's go ahead and save it. So our control panel is working, and we can also control the snakes. We can move it up and down. Perfect. Okay, yes, it's working perfectly. So far we have done a great job. So the next thing we want to do, draw a food somewhere over here on the screen, and the food itself would be in a random position. So let's see where we can call it from. We can call it from here. Okay, so first we draw the snake, and then we draw the food itself. We'll go ahead and define this function. It will have void type, returning nothing. Okay, for food we need a position, and position should be saved in a variable. So we'll call it offset food position, and the food itself should be of piece type. So the type of food we have, it is piece or piece type food, which is this object type. Okay, because we want to use the same Dart file to create food, just like the snake. Okay, well, the first thing we'll do, we'll check if food position is null or not. If it's null, we'll create a position for it, random position, using our get random position, the same function we use to create random position for our snake. And we created a random position, and after position we need to pass it to the piece file or piece object, create a piece object using piece.dart file. So we'll return a value and return it to food. So let's go ahead and create this object, which is piece dot which is piece, actually not piece dot. So we're calling this file over from here directly, and it will have x, y, color, and size value. So pos x. So we'll take the first part of this. Remember, food position is type is offset, so which has x and y value. So food position dx, and we'll turn it to int, and we'll do the same for y position. Food position dot dy dot to int. Okay, and then we'll also have size is step, and we'll also define the color, which we did early. So colors dot red. Okay, so our food position has been generated, and using this food position we also created a piece object, and this piece object has given to food variable, and the type of this variable is also piece. So all we need to do, go ahead and call this object, or call it from somewhere. We call it from here. So let's go ahead and save it, and hopefully we'll see a piece of food somewhere. So this is the piece of food, or piece, or sorry, the food for the snake. So right now we have the snake, and we can control the snake, and we also have the food position. We can eat the food, but it doesn't increase the length of the size, and we also don't have the next random position for food itself. So what do we do? First we'll eat the food and increase the length of the size, and which would be pretty easy to do. We can do it just right from food here. So we'll define a condition here, if food position equal positions 0. So remember, this position has all the positions for our snake, and we are taking the first position, which is the head of the snake. Is head of the snake and food position, they're same. That means there is a collision between food and the snake itself. So we'll eat it. So and we'll do some changes. So first we'll increase the length of the snake itself, and we'll have what else we can have? We can also have, say, score. We can have score plus 5, and we'll also have speed equal speed plus 0.25. so once we eat the food, the snake's moving speed should be higher or faster. Okay, all right, so we don't have these two variables, so which we need to go ahead and define them. So let's go ahead and do it. So int score equals 0 and double speed equal 1.0. okay, that's what we have. And because they're together, because the head and the foot position has collided, we'll create new foot position again. So get random position. Okay, and that's it. So we created the food and we ate it, and then we increase the score. We'll display the score a little later here, and we also increase the speed, but speed needs more action though. We'll do it later. And after that, again, we create a new food position. Okay, all right, and from this food position we create a new piece object, which is a food object. Okay, so let's go ahead and save it, and let's try to eat a food and see if we can eat or not. We have some problem here, as you see. We'll have the problem again. Yes, we have an error, right? This error is happening because each time we eat the food, the length of the snake is increasing, right? Okay, so as you see, what happens here, first, say default, said we didn't eat any food, so currently the food length is the snake length is 5, right? And from this function, so over here, say from the beginning the food length is 5, okay, and over here food length is 5, sorry, snake length, I'm sorry. So until this function, the snake length is 5, and over here snake length is 5 too. But as we eat the food, the length has increased, so which means the length is 6 now. But the position itself, there are only 5 positions, so the 6th position is empty. That's why we are seeing this error, just like the screen you have seen, red screen, because it's throwing an error. Okay, so because we have an position but it's not in the array list. Okay, so for the first timer, when we eat the food, we don't want to add it as a piece object and show it on the screen as a part of the snake. We want to skip that part, and in the next iteration, which will happen over here, so because over here in next iteration length would be 6, and the 6th position will be added here, and we'll see no error because we're eating the food first over here and then run this, but position has not been updated. It means no new positions. So in that case, we need to skip it, and it's very easy to do. So I will create a condition if I equal or greater than or equal positions.length. Do what? If I is greater than this position.length, we don't want to run the loop. We want to skip it. So we can skip it like is in continue. Okay. So when I equals 6, so we'll not go ahead and add a position because there is no position. We'll just skipping it. Okay. Let's go ahead and save it. Run the function again, and everything should be good. Let's try to eat the food. Yes, you see no red screen or empty screen. Perfect. So it is working perfectly. Yeah, so as you see, we can eat the food. All right, so next thing we want to do, change the color of the snake. Okay, and which is pretty easy. We can also do it from here. So all we need to do, check the eye value. So if I is even, then it's red, otherwise colors dot green. Okay, so just check based on I value. If it's I even, then it's red. If it's I is odd, then it's green. Let's go ahead and check it. Yes, so now our snake is colorful. So let's go ahead and eat a food. Yes, as you see, if you eat the food, the color changes again. Yes, so the color scheme is working perfectly. So the next thing we want to do is animate this food itself, okay? And we need to do it over here. Remember, it's a stateful widget, so we can use stateful widget to do animation. And to do animation, we can start the animation in init function, init state function, override init state super dot init. Let's see what's happening here. So why it's throwing an error though. Oh, sorry. It should be within this. Okay, very good. All right. Okay, so to do the animation, to do the opacity animation, we can declare an animation controller and its object. So we'll call it animation controller. Okay, and we'll initialize everything for this animation controller within our init state. Remember, init state gets called automatically. So here we can initialize a lot of steps. Okay, so let's go ahead and do it. Animation controller, animation controller. It takes few objects. The first one is Vsync. Vsync is this, but now it's showing an error because we need to do animation with something called single ticker provide state maxim. So if we have an animation and if we do only one animation, in that case you'd call single ticker provide state maxims. If you have multiple animation, you don't call single ticker, you just call a ticker provide state maxim. Okay, all right, and it takes few other objects and properties. So it also takes a lower bound. We can provide lower bound 0.25 and upper bound 1.0. So lower bound is actually in default, that is the value is 0. In our case, we are using at 0.25. Okay, and we can also define the duration of this animation. So duration, and it takes a parameter milliseconds, and we say everything should happen in 1000 milliseconds, which is 1 second. Okay, and after that we want to start the animation. Okay, so we can call anim controller dot forward. Okay, and within this we start the animation, and there are a few more things that we need to do. So this one is called we can call a status listener, which is animation dot add status listener, this one first, and within this we can do some conditional check. So let's go ahead and take the status object and we check if animation status dot completed, this one, which means the animation has completed, and if it's completed we want to start the animation again. So let's go ahead and start it. Animation controller dot reset. Actually, not starting, resetting. We'll start everything from scratch. Else if, let's take the status controller again, animation status dot dismissed, which has been stopped. If it's stopped, then start it again. So animation controller dot forward. Okay, that's it. Okay, so right now what's happening here, we declared an animation controller, and within init state method we have declared this object, and we initialized it using lower bound, upper bound, duration, and Vsync this. As we are using Vsync, we also need to use single ticker providers state maxin. And after that, we want to wait and listen and see and keep the track of the animation. If it has completed, we reset. If it has been suddenly stopped, we start from the scratch, okay? Or we forward it, we keep running it, not really actually start from the scratch, we keep running it. Okay, that's what it does. Okay, right now, so we are animating something. So what we are animating? We are animating the opacity. All we need to do, call this animation controller object over here. So widget dot now. So this same object, same file, piece.dart, has been used for our snake and the food itself. Okay, so we need to find a way to differentiate when it is snake, when it is food. Okay, so we'll declare another variable. We'll call it final bool is animated. Okay, and we'll put it over here to initialize. So this is animated. The default value is false, which is for the snake, but not for the food. For the food itself, we'll pass it from here. Okay, so is animated true. So this is for the food. Okay, so now we are passing is animated true for the food, and within this within this space over here, we can now, as we passed it, so it comes down over here, so we can grab this. So let's grab it. To grab it, we'll call widget object and then is animated. So if is animated true, then we do the animation. Okay, so we call anim controller dot value. Okay, the value is what? The value is coming from here. It's called interpolated value, which is between 0.25 and 1. Okay, and if it's not true, then we keep it as 1. Okay, that's what we do here. Okay, so now let's go ahead and restart our application and see if the food is animating or not. Looks like the food is not animating. The reason, because let's see, is animated value 1 animation controller, which we already started. Default value is false, and oh, sorry, this was not for the food, this was for the snake itself. So we need to find the food. Okay, food is here. Is animated true. So this is for actually the snake itself. Okay, now let's go ahead and run it again. Perfect, you see this is animating. Now we can edit, and after editing we get a new one. The new one is also animating. Okay, all right, perfect. So the next thing we need to do, we need to show the score object over here, right? Okay, so let's go ahead and do it, and it's pretty easy. So we'll call a function which is called getScore, and getScore should return a widget. So the widget is positioned widget, and it takes a child. The child is text in this case, and the text should have a string, which is this one, and we have the score which we did early, so turn it to string. Okay, and after that we can also define some style for it, and it is text style, and it will have font size, say 30, colors dot white, and it is returning a widget. So the function of this type should be widget itself. Okay, And next we can go ahead and call this function, which is get score. Okay, so now let's rerun the function again, the file, sorry. Okay, as we see, the score is over here. So what we could do, we could define a position for this. So we can define the top position as 80 and the right position, say right maybe 50. Okay, let's go ahead and run it again. Yes, we see the score is there, and if we eat the food, the score should increase. Okay, I'm trying to eat it. This looks like I was not successful. Yes, you see, as we eat it, the score increases. Okay, all right, so we are done with the score. The next thing we want to do is do this collision detection. As you see, it's going over the screen, and if it tries to go over the screen, the game should finish. Okay, so first thing we need to do, detect collision. Okay, so we can detect collision from here before returning the next position, and I already have a function for it. That this function should be this one, which returns a boolean. Okay, I'm sorry, that is my VS code that was running there. Okay, all right, so this is the function over here, and we need to call it from here. So let's call it, and we'll call it using conditional block. So detect collision, and it takes position is this one, and if it returns true, then we do something. Okay, so now let me explain to you this function. All it does, it takes the position that's supplied to get the next position, which is the head of the snake, position 0, remember early. So this is the head of the snake. This function takes head of the snake, and we check it, the expert. If expert is greater than equal to upper bound, which is this direction, x position, and direction equal right, which is this position, then we return true. And if it's less than the lower bound and it was going on the right, the current position, current direction was on the right, then which means it's also collided over here. Okay, so lower bound is here, and less than lower bound should be here. That means it has collided with the lower bound. The same for upper bound. Okay, all right, so if it does, then we return true, and if it returns true, then we want to do something. We want to finish the game. Okay, all right, so to finish the game, first we want to wait and show a message to the user, and to do something like that, we'll call future.delayed. Okay, and it itself takes duration, and duration is in milliseconds, and we want to delay 200 milliseconds, and after that we want to call a function, and this function would show a dialog box. So I already have the function ready, so let me go ahead and find it. So this is the function over here. Okay, so go ahead and do it. I'm sorry, again, I opened the wrong browser or wrong thing. Okay, all right, so I'll call it actually right over here. So let's go ahead and call this, and then I'll walk you through what's happening here. So this function name is show game over dialog. Okay, and we are done. And we should await, because we are using future delayed. So await, and if you have await within your function, the function itself should be async. Okay, and if function is async, then it should return also future, and wrap offset with it future. Okay, now get position is being called from here. So it is async, so we want to await here again. Okay, and if we await, we should itself should be async, the function. But in our case, we are not returning anything, so void is enough. If we return something, that should be future type, which we saw early over here. Okay, we are returning something, not void, so it is future type. Okay, so now let me explain to you this one. So this is a function, and this function is responsible for showing an alert box on the screen. It takes few setup, first two, and then we create an alert dialog box. This dialog box takes four things: background color, shape, title, context, and action buttons. Okay, so shape itself, what kind of shape we want, and what should be the border color and border width. Okay, and if they should have radius, what kind of radius they should have, and the border within it, the title of the text box, and the style, and some message related to it, and action buttons. Okay, and this action buttons also has a name, and after that we also have a function which is on pressed. So that means this action button would respond to on press event, and when it does, we want to restart our animation again, which means start everything again, because the game is over, because we have detected a collision. Okay, all right, so that's what is happening here. Hopefully it makes sense. It's actually pretty straightforward. The only thing is that we have an on press event here, and which starts everything again from the scratch. Okay, so let's go ahead and call this and see what happens. So let's dive over here, and as you see, we have this restart. Okay, all right, so now it's a little weird. So why? Let's go ahead and find it out. So we are calling this one from here. Okay, let's go ahead and return something. What do you return? We return whatever the position has been given. Okay, so this is the position. Okay, we want to return. Okay, let's go ahead and start it. Okay, looks like we have some problem. The problem might be somewhere here. Where is our return restart function? Let's go ahead and find it. So restart is this one. Okay, and before we return anything like restart, let me see. So detect collision, which is returning the true or false. This alert box, and alert box is getting called from over here, which is async, and the future. We should be good. I'm not sure why it's happening though. Okay, I got it. Actually, guys, we need to, once this is detected, we need to stop the timer. Actually, this timer is causing the problem. So let's go ahead and check it. So if timer is not null and timer is active, in that case, cancel the timer. Timer dot cancel. Okay, all right, after this we should be good. Perfect. Okay, so this is what is causing the problem. We have detected the collision. Let's cancel the timer, okay, and restart everything again. Because we didn't cancel the timer, so in show game over dialog, which is here, it was calling restart again and again, again and again. So it was like in a infinite loop. So that was the problem. Okay, all right, so now let's go ahead and restart, but it looks like it restarts from the original position. So we can change it. We can change it from our function, which is called restart. Here, as the game is over and we call restart, and we want to tweak some variables. So length, put it to 5. Score, put it to 0. Speed, put it to 1. And what else? Positions, put it to 0. Okay, and one more thing we need to do, we need to create a random position, otherwise it would still be here. So we'll go, sorry, random direction. So we'll go ahead and create a random direction. We'll call get random direction. Okay, so let's go ahead and define this function. It will return something type direction, get random direction. Okay, and within it, first we'll declare a variable which is int val, and we'll call random.nextInt, which takes 4. It could be why 4, I'll tell you. And after that we put something to direction. Put what? Direction.values.val. Okay, all right. And then we want to return it, return direction. Okay, so all it does, create a random value from 0 to 3 and pass one of these values to here, and takes one value from direction file, which is this one. Okay, so that means we are creating a random direction. Okay, all right, so let's go ahead and restart everything. So let's die and restart. As you see, after restarting, the position is a bit random, and we can eat the food now. And we die and restart again. So the position is random every time right now. So let's eat the food again. Well, looks like I wasn't. Die. Yes, so position randomly start from here. Yes, the score increased, and we can eat the food again. Well, I wasn't. Anyway, so the last thing we want to do with this is increase the speed each time it eats the food, even though we have the speed but we are not using it. So we need to use it. Where do you use it? In our timer function. So let's go ahead and find our timer function. Our timer function should be, okay, let's look for it. Timer, well, it is over here. Okay, so we call it change speed. So you can change the speed over here. So just divide it and return an integer. Okay, speed. So all it does with this, it returns an integer instead of fraction. Okay, so we saw early that each time the snake eats something over here, let's go ahead and find it. Snakes eat something, the speed has been increased. And now over here we utilized the speed itself. Okay, so we'll have a new speed. Okay, we'll go ahead and restart it and play the game, and we'll see after eating food the speed has been increased. It increased a little bit. Let's eat it again. So you see now it's much faster. So it's getting faster and faster. Anyway, so that's all about this game, guys. So hopefully you learned something, and if you learned something, don't forget to smash that like button, and don't forget to share it with your friend and everyone else, and don't forget to subscribe. So I'll see you in next tutorial. Thank you so much.